Okay. Okay, let's get started. Where's the noise coming from?
I don't know. Somebody that on the radio.
Somebody's got something on. I hear it. Interference. Okay, so we will be looking at our homework, and we will be looking at independent and dependent variables. All right, did anyone do their homework?
Sure, word. We have 2 sets.
Did you do the one on the college placement, math, number, and quantity? Because one I gave you, I think, was for later, but one is for today. That was the one that said college placement, math, number, and quantity, algebra, and functions.
I don't think I know.
3, 4, 5. Well, let me bring up my screen. Share my
Well, checking my
screen.
phone. It's in my phone.
Okay. Now, do you see this one? College placement, math, number, and quantity, algebra, and functions. Does everyone see that on the screen?
Yeah, we can see it on the screen.
Okay. Alva, you can't see the screen. You're on your phone. Can you see the screen?
No, Miss Barbara, I'm just listening to you.
Oh, okay. So you can't see it. Maureen, you see it. And Vanessa, you see it. Okay.
As she turns, she phone upside it down, she will see it.
Turn it one.
Cross there. I said, got it up like this, she turn it like this.
No, I'm not seeing nothing.
You got rotation, put it on rotation, and you will see everything.
Go where?
She says turn it like horizontal instead of
Yeah.
vertical. Instead of vertical.
Yeah.
Yeah, but I'm still not seeing anything.
You're still not seeing it. Okay.
No, but I'm hearing.
All right. Let's look at the first one. And that's a function, right? F of X, that's number 3. F of X equals.
Excuse me. Which
Yes.
one is that? Which one is it? The first one in algebra?
College placement, math, number, and quantity, algebra, and functions. 11/22/2021 session. I still hear some talking. Who's talking in the background? I hear talking in the background. Somebody's got something on.
No, it's quiet here.
Maureen, anything on?
No, Miss Barbara.
Miss Beckles, anything on? I hear noise in the background. Miss Beckles, go to mute. Must be Miss Beckles. Miss Beckles, go to mute. Okay. Now, this is the function. So let's just copy this function. Okay. And this says f of x equal 5x times x plus 3. And we're looking for what? F of x minus 3. Now, Maureen, what does that mean? What does that mean? What do we do with the x minus 3? Maureen?
Let's see. The x minus 3.
Yeah, we're looking for.
May subtract it from that?
No. This is a substitution. See, when we say which of the following is f of x minus 3, that means wherever we have a x, we want to put a x minus 3. So that's the input. So instead of f of x, this will be f of x minus 3. Now, wherever we have an x, we want to put x minus 3. That's what a function is. When you're looking for a function, you take the input and you put it in the output of your function and then do the math. All right. So for every x, we want to put x minus 3. So this becomes what? X minus 3. All right. Now we have x again right here, right? So this x becomes x minus 3. So we write this, substitute for x minus 3. Okay, so what is 5 times x minus 3, Maureen?
5 times x is 5x minus 3 is 2x.
No, that's we're talking multiplication here.
Oh,
So what is 5 times x minus 3?
that is 5x is 5x, right?
Okay, so that would be 5x. So let's just put here a 5. 5 times x is 5x. What's 5 times a minus 3?
5 times minus 3 is a minus 15.
Minus 15. That's right, because you're multiplying signs that are unlike. So your product sign would be negative. So 5 times a minus 3 is a minus 15. So this becomes 15. All right. So 5 times x minus 3 is now 5x minus 15. Okay. Now, what is, and this, now we have x minus 3 plus 3. What is that, Maureen?
I hear you. 5 what?
Oh,
You say
x
6?
minus 3 plus 3. What is that?
X minus 3
Plus 3. Yes. What is that equal to?
A 0.
0.
Minus 3 and plus 3 is a 0. So what do you have left?
0, so we have
We have
minus
15.
Where are you getting a
So
15?
we forgot, let's see.
We're looking right here. X minus 3 plus 3. What is that equal to, Maureen? X minus 3 plus 3.
0.
Alba, do you know? X minus 3 plus 3.
it's a 0.
What did you do with the X?
0 x. No,
X
The,
0.
the minus 3 plus 3 is the 0, but you
Yeah.
still have X. So this would be then X plus 0, right?
oh,
Yes.
You can't throw away the X. You still have that X there, right?
Yes.
So now X minus 3 plus 3, and you were correct, minus 3 and plus 3 is 0. So what you have remaining is X plus 0. And X plus 0 is just what, Alba?
It's just 0.
X plus 0?
X.
X, that's right, perfect. Okay, so X plus 0 is just X. So what we have here, let me just put this here, and this would just be times X, right?
Yes.
There we go. So this would be times X. Now we have what? 5X minus 15 times X. Alva, what is X times 5X?
X times 5x. That's 5x.
No.
X times 5x.
Variable times a variable, and they're the same.
The x is the variable.
You add the exponents, and this is like saying, okay, let me put it over here. This is like saying 5x, and let me just put a 1 there, because the default is 1, right? So
Yes.
5x to the 1 power, okay? And we are multiplying that. Let me just put it here. And we
You're multiplying The power.
Well, when we multiply, we add the power. So 5x to the 1 times x to the 1. X to the 1 power. Remember, we
Okay.
don't have to put that. I'm putting that for clarification because 1 is the default. So when you don't see an exponent, then the default is 1. Okay. So now this is what we have here, right? 5x to the 1 power times x to the 1 power. What is that equal to, Alva?
X.
When you multiply and you add the exponent, so add the powers. So what is that equal to?
Would it be X square?
Yes, but you've got a 5 in front of it. You can't throw away the 5. So you x squared is correct, but you have 5 times 1 is 5. So it would be 5x squared. Okay.
Okay. Okay.
5x squared. Okay, so 5x times x give you 5x squared. All
Okay.
right, so let's just copy this and put our 5x squared. Put this here. Okay. Okay, so let's copy. Now this becomes 5x squared. So let's just put our 5x squared here. So 5x times x is 5x squared. So I put my 5x squared here. Now, what's minus 15 times x, Alva?
15 times X is 15X.
That's right. So a minus 15 times x will just give you a minus 15x.
Yes.
And we can take out the 0. So our answer is 5x minus 15x. And that's answer what, Maureen?
Yeah.
What answer? A, B, C, or D?
Yeah.
A. That's answer A. Any questions on number 3? Answer A. Okay, so when you have a function, you have an input and you have an output. Your input is what is in parentheses. That's the x minus 3. Your output is what you calculate over on the right, the 5x times x plus 3. Okay. And the relationship here is what we are doing. And this is a multiplication. 5x times x plus 3 is a multiplication. So just as a review, if you're looking for f of x minus 3, that's the input. So you put that input wherever you see the variable x. So every x is substituted by x minus 3. And you see it here as 5x, 5 times x minus 3, and then x, which would be x minus 3. And then we do the combining of the terms and we get, and our multiplication, the x times the 5x minus 15, that gives you 5x squared minus 15x. Questions? I still hear noise. Miss Beckles, you should go to mute. I don't know if she hears me. Miss Beckles, go to mute. Okay, let's go to number 4. Factorization. Let's copy this and you tell me what are the common factors for these numbers. Okay. 5x squared minus 15x minus 50. What number divides into 5, 15, and 50, Vanessa? What number divides into 5, 15, and 50?
Number. Can you find?
The
Right,
same-
5.
That's right. Perfect. 5. In other words, 5 goes into 5 one time, 5 into 15 3 times,
3,
5 into 50 10 times.
10
So
times.
that's right. So we can factor out the 5. And what do we have left, Vanessa, for x squared? I factored the 5 out of the 5x squared. So
Okay,
what's
so you
left?
have x squared.
That's right. I have x squared left. So let's just copy that. So I have x squared left. Now I want to factor the 5 out of the minus 15. What do I have?
Minus 3x.
That's right. Minus 3x. Because 5 times minus 3x gives me minus 15x. Now I have the 50. 5 times what number gives you the minus 50?
It's 10.
Plus or minus?
Minus 10.
That's right. Minus 10. Any questions on that first factorization? Maureen, did you do that? Alva?
Yes, it is right.
Okay, because 5 will divide.
5 going to 5 one time.
That's right. And the default is the 1.
Going to 5 3 times.
That's right. 5 into 15 3 times.
3 times.
And
yes.
5 into 50 10 times. And since
Yes.
these are both negative, then those numbers that we get here would be negative. Now, what do you call this equation, Maureen? X squared minus 3x minus 10. What kind of equation is that?
This kind of equation.
Yes. Whenever you see a power of 2 on a variable, what kind of equation is it?
That's
What kind? You know?
I can't remember.
Alva, you know, when you have a square on a variable, what kind of equation is that?
Is it exponent?
No, it's not exponential. It's
Is it
not
like
linear. It's not linear. What's the other category?
It was quadratic.
Quadratic. Very
Quadratic.
good. Quadratic. That's the quadratic format. In other words, the quadratic format is ax squared plus bx plus c equals 0. That's the general format of a quadratic. It's a.
Excuse me, Barbara, I'm not so with the class because I'm not seeing anything. But
Yeah.
I'm listening.
Okay, good. But that's good. You recognize the exponential is one of the type functions. So it's exponential, quadratic, and linear. But that's a quadratic, right?
Yes.
So that's ax squared. And I'm writing the general format of the quadratic. So it's ax squared plus bx plus c equal 0. That's the general format of a quadratic equation. You must have a power of 2 for a quadratic, all right? Now, in this equation, Alva, ax squared plus bx plus c equals 0. Now, just as a review, which one of these would be the constant? The a, the b, the c, or the x?
The x.
The x is the variable.
Oh, x is the x, the c,
Well, a or C? Which one would be the constant?
The C.
That's it. Very good. The C is always just a number.
Yeah.
And here the C is the -10. Okay, the B is the coefficient, which is our -3, right? And our AX squared, well, once we factor it out, the 5 is just 1. Okay. Now, how do we factor x squared minus 3x minus 10? So let me just write this as 5. And then we want to put x. And I want you to tell me what am I leaving out here? Okay, now I want to factor x squared minus 3x minus 10. That's our quadratic. And it has two factors, and I'm putting them here as x and x. Now we've got to put what goes in the parentheses, all right? Now think of two numbers that you will multiply to get 10 minus 10, and you add the two numbers to get a -3.
Oh, I see. Okay. Oh,
Vanessa, which two numbers you multiply to get a -10,
mhm.
and you add those same two numbers and get a -3? What are the two numbers?
And you get a -10.
Multiply two numbers, get a -10. Add those same two numbers and get a -3. What are the two numbers?
Okay. 2, 5 is 10.
Therefore, it has to be
Alpha, you're right, 2 and 5.
Yes.
5.
But what are the signs on them?
Okay, since it's 2 and 5.
Well, we know it's 2 and 5. So
So therefore, we use a plus.
which one?
A +2.
Okay, a +2, you said. So let me just put the plus here. And the minus on the 5.
Yes.
Maureen, is that right? Maureen?
+2 and -5.
Yes, is that correct?
It looks so to me.
Okay,
Could
what
be
do you
wrong.
think, Alva? Is a +2 and a -5?
I would say it's +2 plus a -2 and +5.
Remember now, when you add it, you must get a -3.
Okay.
And
Okay.
if you must add it to get a -3, that means your bigger number has to be negative, right?
Yes.
So that's why Vanessa is correct. Maureen is correct. It's a -5. Because a
Yes.
-5 times a +2 gives you a -10,
-10. Yes.
right? And if you
Yes.
add a -5 and a +2, you get a -3. Because
Yes.
when the signs are different, you do what? You subtract. So
Yes.
if you had a -5 and a +2, that would be equal to a -3, which is what we need, right? We need a -3. Okay.
Yes.
So which answer is it?
As I said, I'm not seeing them
You
on
can't
the
see it. Maureen, which answer?
A.
5 times which one?
A.
A says 5x plus 5. Remember, it's 5 times
5
x
plus
plus 2 times x minus 5. So which one matches that? A, B, C, or D? Which one,
5
Vanessa?
plus 5. See?
No, C is 5x minus 5 times x
Oh,
plus
I
2.
see. D.
But D is a x plus
Oh,
5.
God.
Which one is it, Vanessa?
B.
So therefore, it would be
B.
Which one?
B.
B. B has 5 times x minus 5 times x plus 2. And that's exactly what we got, right, Maureen?
Yeah, you're right, Miss Barbara.
Yeah, so it's 5 multiplied by the factors x plus 2 and x minus 5. So that would be answer
Yep.
B. Okay. Any questions on that? So you had to factor 2 ways here, right? First, you had to recognize that 5, 15, and 50 all have factors of 5. In other words, 5 times 1 is 5, 5 times 3 is 15, 5 times 50 is 10. Now, once you factor out that 5, you're left with a quadratic. Then you factor that quadratic. And what tells you that when you came up with the 5 and the 2, what tells you that the 5 is negative is because what? You know that you must have a negative 3x, and to get a negative 3x, your bigger number has to be negative. So when you subtract, you get a negative 3. Questions? Okay, that was number 4. Okay, let's look at number 5. Oh, too bad you can't see this, Alba, the graph.
Yes, Miss Barbara.
We have a graph here of the function above shows the value of a used bike over time. Which of the following is true about the function? A, the initial value of the bike is $300. B, the value of the bike approaches 0 as time progresses. C, the value of the bike is stagnant after year 5. And D, the total value of the bike is $15,000. Now,
I would say it's stagnant.
well, it's not stagnant after year 5 because at year 5 it's going down. See, it's going down. Now, this is in thousands of dollars. Vanessa, what was the value of the bike at the beginning?
Let's see. Let me see value time.
Okay.
5, 4. Miss Barbara, could you expand it a little more?
Okay. Oh, the graph?
Yes, the graph.
Okay. All right. Let's make it bigger. Okay. Here's the graph. I'll make it bigger. There we go. Okay.
Okay, great.
Now you see the graph. You have the time in years and you have the value in thousands. So what was the initial value of the bike, Vanessa?
Initial value.
When we started, what was that value?
At this is not 4. It's 3.
3,000. That's it. Very
3,000.
good. That's it. 3,000. So we know then it can't be the one that said it's what, 300?
Oh, it's not
It can't be A because A said the initial value of the bike is 300. Okay, but the initial value of the bike is 3,000. So it can't be A. The value of the bike approaches $0 as time progresses.
No.
No, it doesn't.
No.
But there's a 0 right there for the value of the bike, and isn't it coming down? Isn't it coming to 0? Yeah, it's approaching 0. And the value of the bike is stagnant after year 5. Year 5 is right here. It's not stagnant, it's going down. Stagnant means it would be staying the same.
Yes.
And the total value of the bike is $15,000. No, it started at 3,000. It's not going up. It's going down, right? So what's the answer?
B.
The answer is B. That is correct. It's approaching zero as time progresses.
Okay, that's what because I was working on few of them.
Okay.
And
Yeah.
I did work on that one and get 0 also.
Yeah, it's approaching zero. So that's answer
Yeah.
B. It's approaching zero. Okay. And you can see it here on the graph. It's going
Yeah.
down. The value
going down.
is going down as the years go, right?
Yeah.
So when you get to 15 years, your bike is really about zero, because zero is right here. Started out 3,000, and we call that what? Depreciation. It's depreciating.
Yes.
Okay. Any questions on number 5?
I think that one is correct.
Okay, very good. But some people said 300, but notice you've got to, when you read your graph, you've got to see what it says. It says value in thousands of dollars. And Vanessa said, see, 1, 2, 3. It's right here at 3. That's $3,000. That's the initial value, not 300.
Yes.
Okay. So you got to look at your units, see how they expressed, so you don't make the mistake. And that's a common mistake. People says 300 because they see the 3, but they don't look at it says thousands. Okay. All right. Maureen, did you have that one right?
Yeah.
Okay. All right. Number 6. We're talking profit made on selling textbooks. The cost in thousands of dollars of producing X thousands of textbooks is cost of X, that's the cost function, is equal to X squared plus 10X plus 30. The revenue also in thousands of dollars is revenue of X, that's the revenue function, equals 4X. That's 4 times the thousands of textbooks. All right. Find the profit or loss if 3,000 textbooks are produced. Now, someone want to tell me how to find that? Okay, let's.
Let me see the cost number 6, right?
There's, yes, number 6. There's the cost. Let's copy the cost. And remember, the X is the 3,000. Okay. All right, that's the cost. And the revenue, that's a function, the revenue function is 4X. 4 times the number of thousands of textbooks sold.
Yes.
Okay, there's the revenue. And your profit is equal to revenue minus cost. So your profit will be equal to what? Your profit, and we'll call that P, is equal to the revenue minus the cost. So that would be the R of
If the
X.
total is 3,000, with 3,000 is principal, right? Am I going right?
No, 3,000 is the number of textbooks produced.
Oh,
So revenue of X minus cost of X, that's going to be your profit. So revenue of X minus cost of X, that's the profit. So if you substitute those the output over here, this is the input, X squared plus 10X plus 30 is the cost, and the revenue is the 4X. So substitute the 4X minus the X squared plus 10X.
so we have to substitute. What are we substituting it with?
with the 3,000, because 3,000, it says if 3,000 textbooks are produced and X producing X thousands of textbooks. That's what your X is, your input. And they tell you that the 3,000 textbooks are produced right here. So your X is going to be your 3,000. So
Is
questions?
so where X is? What would be?
Well,
put-
R of X is 4X. So this would be, when you substitute, this is going to be P equal what? 4X. That's the revenue. Minus the cost, which is this, X squared plus 10X plus 30. Okay, so what is your revenue? What is 4X? What is that equal to? What's 4X? Anybody?
That's 4X.
Yeah, but X is what?
2,
X is 3,000.
3,000.
Mm,
So what would 4X be equal to?
12,000.
12,000, right? So 4X would be 4 times 3,000,
3, 4 is 12. That's
and
12,000.
that's 12,000. That's your revenue. Okay. Now, what is your cost? What would cost be equal to? Well, we don't have to use the actual, since it says 1,000, we can simplify our work and just use the 3, and then we can convert it to thousands. Okay, so that's 4 times 3 is 12. So we don't have the big numbers. Okay, so that cost would be, let's take this formula for cost, put it here, equal. Now, so X would be what? What is X? That's our 3 for the 3,000, right? So this would be 3. Okay, and then this would be what? What is X again? 3.
This is 3.
3 fourths.
Okay, so that's 10 times 3. All right. Okay, so what's 3 times 3?
9.
Okay, so just copy that and then do our do the power first. So that would be 9. What's 3 times 10?
30.
30.
30. Okay, so this would be 30. Okay, 10 times 3 is 30 plus 30. And what is that equal to? 9 plus 30 plus 30 equal
Oh,
what?
69.
9.
69, right? Okay, so our cost is 69, right? And our revenue is 12. So profit, we said profit is equal to what? Revenue, R, minus cost. Okay,
Cost.
this is, let me just put here, equal revenue. Put it here, revenue equal. Okay. Okay, now. So
What's revenue equal to?
the revenue is equal to 12. The
Okay,
cost is 69. So when we substitute, let's just substitute those values here. So this would be revenue, that would be P. Revenue is 12 minus cost is 69. So what's 12 minus 69? What is it equal to?
57.
Plus or minus? Alva, plus or
Plus.
minus? Alva,
a
12,
plus.
12 minus 69.
12 minus 69.
Yes, a plus 12, a minus 69. You do a
So that-
subtraction, so what do you get, Alva?
That's a plus 12.
A
A
plus,
minus.
no, a plus 12 and a minus 69.
Oh, so you go
Unlike you subtract, so what do you get?
unlike you subtract. So you
Yes.
get okay, 5. 57.
Plus or minus?
A minus 57.
That's right, minus 57, because you've got more minus than plus, right? But
Yes.
this is in thousands. So we just take our minus 57
Yes.
and multiply it by 1,000, since we know this is in thousands, right? And that
Yes.
would give you minus 57,000. So is that a profit, or that profit, is that a loss or a gain?
I would say it's a loss.
It's a loss. So
Yeah.
you lose 57,000. So let's see, what answer would that be?
B.
A 57,000 loss,
D.
Alva.
D.
D, that's right, because
Yeah.
D is a loss. So your
Wow.
answer would be D.
Yeah, but I don't have the answers in front of me.
Yeah, okay. But the answers were, let me just go over the answers. 21,000 loss, 57,000 profit, 3,000 profit, or 57,000 loss. But once we found our revenue was 12 and our cost was 69, we know we have a loss. And a loss is 57. So the 57,000 loss is answer D.
Yeah.
Miss Beckles, go to mute. She doesn't. Oh my goodness. Okay. So the answer would be D. Any questions on that last problem?
No,
I wonder-
because it's just a loss.
Yes, it's a loss. See if I can text Miss Beckles to go to mute. Because she's not hearing me. See if I can. I want to tell her to, I think it's her. Please mute. Yeah, I think it's her, because she's open and I think she might be at work. Okay, any questions on that last problem?
No, I don't have any.
Okay, All right.
Both.
All right. Now let's look at independent and dependent variables. Okay.
I have pages 7 to 9. If I'm what? I only have on the president, page 7 to 9.
New share.
Miss
Let me
Barbara,
go.
Miss Barbara,
Yes.
I had worked that one out for myself. I was gonna text it to you, and I get dependent,
You get one?
dependent variable,
Okay.
dependent.
Let me go back here. Let's see. I want
I
to.
did that one, but I just didn't get to finish up to text them to you.
Independent variables. Okay. Okay. All right. Number one, a freight train moves at a constant speed. Does everybody see independent, dependent variables?
Yeah.
Yes? No? You don't see it?
I see it.
Does everyone see
Yeah.
that? Okay. All right. So we have a table here with the input and the output. A freight train moves at a constant speed. The distance y in miles that the train has traveled after X hours is shown in the table. The time in hours is X. The distance in miles is Y. Okay, so I want you to identify the dependent and independent variables and then write an equation to represent the relationship between the variables. So first, let's do our independent and dependent variables. I text Miss Beckles to mute her phone, but I don't think she's checking her phone.
No, I'm here. It's still working. Here.
Miss Beckles, mute yourself. I just text her.
Okay, so we. All right, so.
It's disturbing today, a lot of noise.
Yeah, I know. I think it's from Miss Beckles' side, and I just text her to mute herself, but she's
Okay.
probably not checking her phone.
It is quiet in my house.
Miss Beckles. No, she's got just the banner up, so she's someplace else.
Oh, okay.
I think she's probably at her other site. Can somebody else text her? Maybe she'll, I don't know. I text her to mute herself. Could somebody else text her? Maybe.
If I get,
I just text her to mute herself, but I don't think she's
if I
checking.
get up,
She's
I'm
probably
not-
not checking. No, Alba, don't you do it because you're on your phone.
although I'm not seeing you, but I'm learning.
Good. Okay. All right. Now, what is the independent and dependent variables? Now, you have either the time in hours or the distance in miles. So what is the dependent variable, Alba? Which one did you say?
I say dependent.
Which one? Distance in miles or time in hours?
The distance.
Oh, you say the distance is the dependent variable?
Yes.
Okay, so let's put distance in miles. So the independent variable, you're saying the time in hours.
Dependent.
Okay, you said the distance in miles is dependent upon the time in hours.
Yes.
And that is correct.
Yeah,
Now,
I'm
that
right.
that is correct. Very good.
Miss
The
Barbara, I'm
dependent
right.
variable distance traveled is dependent upon the time traveled, right?
Yes, yes.
Okay. Now, what is the equation to show the relationship between these variables? Now, you have to determine that from the table, right?
Yes.
Now, since you said the dependent variable is the distance in miles, that would be y, right?
I was looking over some yesterday, but
So y equal, so what would y be equal to? Oh, she
45.
must have looked at it because she went to mute.
I text you just now.
Yeah, good. That's why I say somebody else texted her, because I texted her. Now she went to
I
mute.
called her.
Oh, that's good. That's why she went to mute.
I called her and I told her. She answered and I told her.
Oh, thank you. Thank you.
You're
Because
welcome.
that was disturbing. Dependent variable, distance in miles. How is that related to the independent variable, Vanessa?
Mm.
How is y related to x, the time?
Because it gives you time in hours. What is that we do it? The distance.
But how is it related?
You know,
How is the dependent variable distance and miles related to the time in hours?
time.
Distance was 135, right?
It talks about not time. It got next one. Time and hours is one word for this thing, not time, not
Well, you would put like
cannot remember.
3 hours. And the other one is 135. Plus 135. I know.
Yeah, that's 135. But how do you go from 1 hour to 45 and then 2 hours 90? What is the relationship there?
45.
45. So what do you do with the 45?
God damn.
No.
You put the
Remember, the relationship has to be between the distance in miles and the time and hours. What do you have to do?
you're going to put like 3.
What do you do to the time in hours to get to this distance, the output? What is it? That's it. Go ahead, Vanessa. You're right. You multiply. You multiply what?
Multiply 45
That's it. Times what?
x.
X. That's it. Excellent. Yes, you multiply 45 times the time in hours. And look, you can see that, right? 45 times 1 is 45. 45 times 2 is what?
It's
90. And 45 times 3 is 135. All right. Now, if you travel 5 hours, okay, 5 hours is the time traveled.
Mhm.
Now, since you have your formula, right, you could find the distance you traveled, right? So you say distance,
45 times 5.
what would it be? What would it be, Vanessa?
5 times 5. I can do it out my head. 5 times 5 is 25.
5
5
times
fours
what?
is 20 and 2 is 22. 2 25.
Yeah, 5 times 45 would be equal to 5. So you could
Yes.
find the time, you could find the distance traveled for any number of hours. You just multiply that by 45, right? So if you travel 5 hours, it'll be 5 times 45 is 225. All right.
Mhm.
If you traveled 10 hours, will be 10 times 45 of 450. Questions on number 1? First, identify your dependent variable, and your dependent variable is your output. That's your Y, your output. Your input is your X, the time in hours you traveled.
For your input is your X and your output is your Y, right?
That's right. Yes. Every and this is really a function. It's just functions can be expressed like variable equals relationship between the input, or it can be f of y or whatever, but it's still a function. So identify dependent variable, identify the independent variable. All right, let's go to the next one. And the next one involves train travel and train fare. That one was distance and time. This is fare. Train fare and distance in miles. Now, Maureen, what is the dependent variable?
Miles.
What is it?
Miles.
Dependent variable?
Mhm.
What is the independent variable?
The train travel, the train fare.
So you're saying the miles is dependent upon the fare?
Yeah.
Alva, what would you say?
The fare is dependent on the mileage.
That's right. The fare is dependent on the miles traveled. So
Yes.
your dependent variable, Maureen, would be the train fare.
Yes.
Your train fare in dollars is dependent upon the distance in miles. So that would be distance in miles. Okay. All right. Now, okay. So what would be the equation, Maureen?
Equation would be, let's see.
The dependent variable is the output. Okay. So Alva, you said the dependent variable was a train fare in dollars. That's T.
Yes, Ms. Barber.
Okay, so T equals, now let's see. What's the relationship between T and M? The train fare in dollars and the distance traveled. What's the relationship?
Are you talking to me, Ms. Barber?
Well, you can't see the table, so that's a
No,
problem.
I can't, yeah.
Does anyone see a relationship there between the distance traveled in miles versus the fare?
Distance traveling miles and the fare.
Right. T
If
is
you travel T is the
That's the output, T. And how is that related to the distance, Vanessa?
output, and the output is Y.
Well, it's T here. We're using T as the fare.
Yeah,
That's
but,
the,
Okay, I'm back now. I was sorry to my nerves.
okay, but
Oh.
the T
uh-huh.
is the output, right?
Right. How's that related to the distance in miles?
Okay, and if you look at it on a graph, will it be Y?
Well, T is like a Y if you're using X
Okay.
and Y, yes.
I
And
just want to get it.
X would be the input.
Oh, the
Okay,
distance would be 2.
okay. This is
What would it be?
2.
Maureen?
2.
2 what, Maureen?
And 2x or 2m. 2 miles, right?
But the miles is
what?
in M.
this is
Yeah,
Y.
so it'd be 2m.
So therefore, T, which is the Y, T
Right.
equal to, just now, T equal to M. That's what Maureen was saying, right? Maureen, go
2m
ahead.
because the miles is 2. So it'd be 2m.
And what
Which is
else?
Plus,
plus
Vanessa, what's next?
okay, let me
Plus
see.
what?
n.
Plus, one moment. Plus 10. Where is it? Where's 2?
2
No.
times the number of miles plus 10.
Plus 10. How did
Because
we get?
if the miles is 0, 2 times 0 is 0 plus 10, and you get 10 here. So even without traveling, you're going to pay 10. So that 10 is like a constant,
Okay.
right?
Mhm.
All right. And then if you go 1 mile, 2 times 1 is 2 plus 10 will give you 12. 2 miles, 2 times 2 is 4 plus 10, get 14. 3 miles, 2 times 3 is 6, plus 10 is 16. If you went 10 miles, it will be 2 times 10 is 20, plus 10, 30. All right?
Okay, so where the M is, where the next to the 2, you put in, let's say you put in 2, right?
Yes, because
So
you
you
must,
2 times 2 is 4 plus 10 equal to 14.
that's right. So it's like the 10, like this is like y equal mx plus b. That's like your y-intercept, right? The 10.
Okay.
Okay. 10 is like your y-intercept. The 2 represents your what? Your slope. If it's changing by 2. So if you change your distance by 1, you change your train fare by 2, because you have a constant 10 that's always added. So the only thing would be changing would be the distance in miles. So as your miles go up, then your train fare goes up by 2 times. Okay. So which means you could find the train fare in dollars for any distance. You just substitute the distance for M multiplied by 2, and then you have your train fare. Questions? All right, now you try the next one, number 3. Let's look at number 3. Okay.
Number 3.
Okay. Number 3 deals with pages and minutes.
You got to bring it back though. Good.
There we go. All right. So we have number of pages typed versus the time taken in minutes. So according to your table, 1 page takes 4 minutes, 2 pages take 8 minutes, 3 pages take 12 minutes, 4 pages take 16 minutes. So, Alva, what's your dependent variable?
That I just spoke about.
Yeah, the number of pages, P, or the time in minutes, M. Which one is the dependent variable?
Remember, I'm not seeing it right now.
Yeah, I
Mr.
know. We're talking, well, I'm giving you the 2 variables. One of them is input, one is output. Is the number of pages input or output? Or is the time of minutes input or output? The input, the output would be the dependent variable. So
Mhm.
would it be the time in minutes to type the pages, or would it be the number of pages? Which one would you say? Dependent variable.
I would say the time in minutes.
Okay, so time in minutes,
Mhm.
that's the time in minutes to type the pages. So that means your independent variable
Is your why?
would be what? The number of pages.
What's anything with time, but carry something to the back of it, right? Because you have to multiply, right?
Right. So independent, let's see. Okay. Now, let's do our equation. Now, Alva said the time in minutes was the dependent variable. That's correct. Time in minutes is dependent upon the number of pages that you type.
Mhm.
Okay. Very good, Alva. You're really good at this.
Thank
So,
you.
so let's write our equation. What is our equation?
Our equation, therefore, one moment is number of pages, right?
Yes.
Pages. So therefore is P.
Well, the dependent variable is the time in minutes. So that would be M.
M.
That's your output.
M. Yeah.
What is that equal to, Vanessa?
Okay. M equal to 4.
Okay.
Am I right?
Yeah, you're right. Number of pages represented by what variable? It's in the table right here.
Yes. 4P.
That's it, 4P. That's correct. Because if P is 1, then 4 times 1 is 4. If
4.
P is 2, 4 times 2 is
8.
8. P is 3, 4 times 3 is 12. P is 4, 4 times 4 is 16. If P was 5, 4 times 5 will be 20. So there's your equation. M equals 4 times P. Questions number 3.
Miss Barbara really make ensure that, you know, you got to think real.
This is really, really good how you can figure the table, or you can figure it from a graph. I think we may have
I
a
like
graph.
doing it with the graph. I'm
You
telling
like the graph better, right?
I like
That's,
the
I know you do. Well, sometimes it's easier to read it off the
I know
graph than
it's
a
better
table.
both ways, but I like graph. I like graph. Any day when it comes to the graph,
Okay, now let's look at, well, I know everyone knows this one, interest. Let's see. Let me,
it's independence and thing.
okay, we're talking time in years and interest. What is the, Maureen, what is the dependent variable?
Time in years.
What is the dependent variable?
Time in years.
Time in years? Time in years is dependent upon interest?
No.
Time in years versus or the interest.
The interest is dependent upon the time in years. So dependent
Okay.
variable is the
The interest.
interest in dollars. So the independent variable
Be time in years.
would be the time in years.
Years.
Okay, so we have our dependent variable. We have our, put that here. We have our independent variable. That's the time in years. Now, what's the equation, Maureen?
Okay.
And the dependent variable is the interest. So that would be our I, right? So what is our I equal to?
Equal
That's
to
You can tell from your table, the relationship. What is it?
the time in years is 4.
What is it, Maureen?
4.
4-1.
oh
What?
no.
4 why?
No.
How do I go from time in years to interest? What's the relationship?
You have to add,
It's not add,
multiply.
multiply. So what are we multiplying, Vanessa?
We're multiplying 12
Right? By what?
by years,
That's right, which is what?
which is y.
That's it. Interest is 12 times y. So when y is 1, 12 times 1 is 12. That's the
12.
interest. When y
Mhm.
is 2, 12 times
Times
2
2
is 24.
24.
When the years are 3, 12 times 3 is
It's
36. And when the years are 4, 4 times 12 is 48. And if it was 5, 5 times 12 will be 60. So that means for any number of years, you could calculate the interest because you just multiply 12 by whatever that number of years is. Questions? Number 4. Alva, too bad you don't see the table, but I'll be sending you this so you can look at the table and see how they relate,
I
how
have
they,
to send on my email, Miss Barbara, but because I'm using the phone now, I cannot look at it at the same time.
and you didn't have a way of printing it out, right? If you
Excuse me?
do you have a printer, right?
No, I don't. I have
Oh,
a computer, but the computer is down now.
okay. Yeah,
And
because you could print it out and then look at, have your hard copy sometime when you're
yeah,
doing this. Okay.
I could get it printed out too. I could go across the street.
Okay.
There is a fax machine there,
Oh, okay.
so I could ask them to print it out.
All right, let's go to number 5.
Mhm.
Okay, I want you to look at number 5 and I'll put here independent variable. Independent variable.
So the independent is the one that stands by itself, right?
Yeah, the independent variable,
Anything
remember that's
in-
always the input. The dependent variable is the output.
The independent variable
Is the
input.
input.
The independent
That's
variable
the input and the
is the
dependent
input.
variable is the output. That's
So
a
the
good way of, yeah.
so
So when you're doing your equation, your dependent variable is the one on the left. And I say that's equal to a relationship between the independent variable.
So the independent is the, okay, let me think about the graph and I would be able to get it there.
freight truck moves at a constant speed. The distance y in miles that the truck has traveled after X hours is shown in the table. So first, independent variable, dependent variable. What would you say, Alva? The independent variable, the time in hours or the distance in miles? Which one is the dependent variable?
The independent, is it,
Which one is the dependent variable? The time in hours the truck travels or the distance in miles?
the time and hours?
You say the time in hours, that's
Yes.
dependent upon the distance?
Dependent is the miles and time. Dependent variable.
What is the dependent variable? Is it the distance in miles the freight truck travels, or is it the time in hours it travels?
The time and hours?
Is that independent or dependent?
Dependent.
Okay, so the time in hours is dependent upon the distance in miles?
Yes. I would say that.
What would you say, Maureen?
It's the
The dependent variable, Maureen, you said is what?
independent variable.
No, what is the dependent variable?
The distance in miles.
Yeah, the distance in miles, Alva,
Okay.
in miles is dependent upon the time and hours that the truck travels. So time in hours.
That's a dependent.
Time and hours is independent. That's the input. In other words, you put in the time and you can calculate the distance. So the distance in miles, which is y in our table. So that's y equal. Now, what's the relationship here? Maureen, what's the relationship?
Okay.
Y equal what?
60.
Okay, y equals 60. What else? Time in hours is given as X. So that would be what?
$60X.
That's right, 60X. And you can see it from the table, right? When X is 0, 60 times 0 is 0. When X is 1, 60 times 1 is 60. When the time in hours X is 2, 60 times 2 is 120. When the time in hours is 3, 3 times 60 is 180. All right, so every hour it goes 60 miles. So what does that tell you? What is the 60? What would you say that in terms of distance, time, and rate? What is the 60, Maureen?
Is miles.
60 is rate. 60 is rate. In other words, 60 is rate of speed. We can say 60 miles per hour. 60 miles per hour. So this truck is traveling at a constant speed of 60 miles per hour. So every hour it travels, it goes 60 miles, right? So if he travels 4 hours, he would have gone 240 miles. Questions?
No.
All right, Alva, so you understand now why your dependent variable is the distance that you traveled.
Yes.
Yeah, that's the distance you traveled, and that's dependent upon the time in hours you traveled.
Yes.
Okay,
Yes.
all right. Okay, that was number 5. Let's go to number 6. Okay. All right, Vanessa, we've got your graph here. All right, let me. Okay, I want you to identify the dependent and the independent variables in this problem. And you're given on the X, you see time in months. On the Y, you're given the height in inches. Now, this is multiple choice. So let me just I'll put this. Okay. Okay, so you identifying the independent and the dependent variable. What is the dependent variable, Maureen? Is it the time in months or the height in inches?
Okay. The independent is
Which one is the dependent variable? The height in inches or the time in months?
I think it's the time in heights.
I mean, well, not time in heights. It's either time in months or height in inches.
Or
So what is the dependent variable?
the independent variable, let me see, time in height.
Time in months.
Time in months, that's here on the X. And height in inches is on the Y.
So the time in heights.
No,
Height
time in months.
in
Month.
That's right here on the X line. And the height in inches is on the Y line. So this is Y is your output. So we said the output is your dependent variable. So which one would it be? A, B, C, or D? A says independent variable as time in days, dependent variable as height in inches. Well, we know it's not A because the time is given in months, right? B says independent variable is time in years, dependent variable height in inches. Can't be B because the time is given as months.
So it's C.
Yeah. C says independent variable is time in months, dependent variable is height in inches. That would be the correct dependent variable. The height in inches is dependent upon the time in months. Okay, so the answer would be C. And of course, D is wrong because this is height in meters, right? Answer C. But the height is not in, the height is in inches, not in meters. Okay, so the answer would be C. Questions on that graph? Okay, I think the next one is a graph also. Okay. All right. All right. I want you to look at number 7. Give you a chance and look at it. And sorry, Alva, you can't see it, but this is one where you have clay available for the class and the clay bought by the teacher. And this is on a graph, and you are to answer the multiple choice as to which one is the independent variable and which one is the dependent variable. So clay available for the class is on the Y. That's your output. The clay bought by the teacher is on the X line, and that's the input. So your choices are independent variable is clay bought by the students. Dependent variable is clay available for class. B says independent variable is clay bought by teacher. Dependent variable is clay available for class available for teacher. C says independent variable is clay bought by teacher. The dependent variable is clay available for class. D says independent variable is clay bought by students. Dependent variable is clay available for teacher. So what is your answer, Maureen? What did you say?
C.
Available.
Clay
Yeah.
bought by the teacher.
Yeah, the dependent variable is on the Y line. The clay available for the class, and the input is the clay bought by the teacher. So that only matches C. Questions?
No,
Okay,
the teacher,
because the
the-
teacher bought the clay, Alva, and the
student.
clay available for the class is from the clay bought by the teacher. So
Yes.
you pick the choice that says the independent variable clay bought by the teacher, that's input. Dependent variable, that's the output, is clay
so you want to become the
available for the
output.
class. Yes, dependent variable is the output. And here that's on the Y line. And the clay bought by the teacher is input, that's on the X line. Any questions on number 7? Okay. All right, let's look at the next one. It's another graph. Okay. Now this one involves phone bill in dollars and number of minutes you on the phone. Alba, which one would you say the independent variable? The phone bill in dollars or the number of minutes you use?
The number of minutes,
Which one is the dependent variable?
the number of minutes you use,
Is that independent or dependent?
I would say is dependent.
The number of minutes is dependent upon the phone bill?
Yes,
Your phone bill now. What determines what you pay on your phone?
okay. The amount of what you pay on your phone depend on the amount of minutes that you use.
So the dependent variable is what?
I would say the phone bill.
Yeah, what's the dependent variable then? You just said what you pay on your phone bill is dependent upon your number of minutes. So what's your dependent variable? The phone bill in dollars that you pay, or the number of minutes you use? Which one is dependent?
The number of minutes you use.
The number of minutes you use is dependent upon your phone bill in dollars?
Yeah, because it's the amount of minutes you use, you have to pay for
But
that
you-
amount of minutes. So
But
it
you pay based on what?
based on the amount of minutes you use.
So the amount you pay is dependent upon what?
And the minutes.
So what is the dependent variable? What is the dependent variable?
Dependent variable is what you pay.
That's right. Your phone bill in dollars, which is on your Y line here, is your dependent variable. And that's dependent upon your number of minutes, which is your independent variable. Just
Yes.
remember, your number of minutes is your input.
Yes.
Your number, the amount you pay in dollars is your output. So your output is always your dependent variable. Okay, so you're given choices here. One says independent variable is number in minutes, dependent variable is phone bill in pounds. Well, it's not that one because your phone bill is given in dollars.
Yes.
B says independent variable is number in minutes, dependent variable is phone bill in cents. Well, that's not correct because your phone bill is in dollars, right?
Yes.
And then C says independent variable is number in hours, dependent variable is phone bill in dollars, but
We're
your
still on
number
7.
is in minutes.
Are we still on 7?
Yeah, we are in.
We're on
Okay.
number 8. So 8D says independent variable is number in minutes, dependent variable is phone bill in dollars. That would be your answer.
Yeah, which is D.
That's right, D. That's
Oh.
it. It would be D because your independent variable and on your graph, that's number of minutes on your X line. And on your Y line is your phone bill in dollars. So
Yeah.
for number 8, the answer would be D.
D.
Questions? Number 8.
No, I'm not seeing it, but I'll go back and retrack it on my phone.
Okay. All right.
Yeah.
Okay. So we've looked at ways you can identify independent, dependent variables using graphs or using tables. Okay. Now let's go. I think we have all right, I have some for you to do. Let's see. Let's do this. Okay. Now I have 5 here and I want you to do those. I think you have enough time to do those, okay? I want you to tell me the independent variables, dependent variables. The first one, Alva, is the more tickets I sell, the more money I have. So number 1, independent variable.
Which one is that, Ms. Borough? Number 9?
Yeah, these are some for you to practice on. I want you to identify them. Okay.
Okay.
So independent variable and dependent variable.
Okay.
For each one of these, and there's 5 of them. So the first one is the more tickets I sell, the more money I have. So you identify your variables. Is it the tickets you sell? Is it the money you have? Which one is independent? Which one is dependent?
The money is independent.
No, I just want you to do, I want you to do all 5 of them. Then I'll come back and ask you what are they?
Oh,
So number 1, the more tickets I sell, the more money I have. So
You got to bring
identify.
them more further up, Miss Barbara, because you can't see, you can't read 2, 3, 4 off, but you can't see the rest. All the questions.
You can't see them all. Okay, let me. Make this bigger.
Remember, I cannot see them as bubble.
Yeah, I know. That's why I was calling
Yeah.
them out for you. Okay. The more ticket size cell, can you see it now, Maureen?
I got to send your picture up to the top of the laptop because I when it get to like shopping buys from, you can't see nothing else. So I gotta switch you first the other side.
Which one you can't see?
Okay, I got good. I can see all now.
You can see them now? Okay.
Yeah,
All right.
twice
The
switch
more
picture.
tickets I sell, the more money I have. So I want you to identify the independent variable, identify the dependent variable. And then when you get to number 2, Judah brings reusable shopping bags from home whenever he goes to the grocery store. The number of bags he brings is based on how many products are on his shopping list. So identify your independent, dependent variable. Is it the number of bags or is it number of products on the shopping list? Which one is independent? Which one is dependent? 3, at a deli counter, the price of a customer's order is based on its weight. What is the independent variable? Is it the price of the order or is it the weight? Which one is independent? Which one is dependent?
I would say the weight.
Okay, so I want you to give me answers for all 5. Now, the 4th one, Vera and Elizabeth are going hiking and are trying to figure out how many snacks they should bring with them on the hike. The longer they plan to hike, the more snacks they should bring. What is the independent variable? Is it the number of snacks or is it the length of the hike? And the last one, as a plane descends, the more time that passes, the lower the plane's altitude is. What is the independent and dependent variables? Is it the time that passes or is it the plane's altitude? Which one is dependent? Which one is independent? Okay, so I need you to identify those for all 5. Okay, 3. Okay, you have a few minutes to do those. Anybody having any problems on any of them?
Well, the last one,
As a plane descends, the more time that passes, the lower the plane's altitude. So you have time and you have what? You have time that passes during the descension of the plane, descending of the plane, and you have the plane's altitude. So one is dependent and one is independent. To identify which one is independent, which one is dependent.
Well, I would say one after depend on the altitude.
No,
So,
write them down now for each one, and then I'll ask you which one.
okay.
The first one, Alva, the more tickets I sell, the more money I have. So you write down independent variable, dependent variable. You have the choices, the number of tickets sold, the money you have. Which one is independent? Which one is dependent? Okay, that's number one. Number two, your reusable shopping bags you take is based on the products on your shopping list. So you have two things, the number of shopping bags you take and the products on your shopping list. Which one is dependent? Which one is independent? And number three, you buying at a deli and your price is dependent on the weight. So which one is independent? Which one is dependent? The price of the order or the weight of the order? Which one is independent? Which one is dependent? And number four, you taking snacks on a hike. The longer you hike, the more snacks you should bring. Which one is independent? Which one is dependent? The length of the hike, the snacks that you bring. Okay. And then the last one, of course, the plane descends. More time that pass, the lower the plane's altitude is. You have two choices here. The time passed during the descending and the plane's altitude. Which one is dependent? Which one is independent? Okay, you have 5 more minutes and then I'll ask you what are your choices. Do all 5 of the practice ones, okay?
Hello?
Yes.
Oh, okay, you're still here because someone just came in on the phone.
Oh, okay.
I got cut off. Yeah. Mm.
Okay, you got about 3 more minutes. Okay, let's look at the first one. Alva, the first one, the more tickets I sell, the more money I have. Tell me your independent and dependent variables.
I would say the amount of ticket that I sold.
Is that
Yeah.
independent or dependent?
Yeah.
It's depend on the money, says independent.
Okay, so tickets sold. Is the independent, so the dependent variable is what? The
The
money.
ticket.
No, you said that.
The more ticket I sold, it's depend on the money.
No, the money you have depends on the ticket sold.
Yes.
So dependent variable is the money you have.
Yes.
So the money you have, that's the output, is dependent upon the input,
Input.
the tickets sold. Okay.
Yes.
So tickets sold. Did everyone have that one? Maureen, did you have that one?
Yeah.
Tickets sold, input, money you have, output. So the money you have is dependent upon the ticket sold. All right, that's Vanessa, you had that one? Okay. All right, let's go to number 2. Okay, number 2, you have reusable shopping bags and the number you have based on the products on your shopping list. Maureen, which one was your independent variable? Which one was your dependent variable?
Which is not number 2?
Number 2.
Okay. The one that number 2 I put the independent one is Jordan bring reusable shopping bags from home. Okay. The shopping bags from home.
Which one is the independent variable? Which one is the dependent variable? And your choices, your products on your shopping list or the number of reusable bags. So which one is independent? Which one is dependent?
Dependent is, oh, I see. Dependent is, let's see. The dependent is the groceries. I don't know if I'm reading it right.
Which one is independent and which one is dependent variable?
One is the number of bags. I don't know. Yeah, I have to look like that.
How do you determine how many reusable shopping bags you take to the grocery store? What determines how many bags you take?
But the amount of things you buy.
Yeah, the products on your shopping list. So the dependent variable is the number of reusable shopping bags, right? Okay, so your dependent variable would be your number of reusable shopping bags. And your independent variable would be the number of let's see, bags. Okay. The independent variable would be the number of items on your shopping list, right? Okay, so that would be products on your shopping list. Okay, in this case, it's Judah. So the products on his shopping list, because we said Judah here. The products on his shopping list determines the number of bags he takes. All right. So the dependent variable is the number of reusable shopping bags. What is that dependent upon? The number of products on his shopping list. Okay. Alva, number 3, a deli counter, the price of a customer's order is based on weight. So what is the independent variable? What is the dependent variable? The price of the order or the weight? Which one is dependent? Which one is independent?
I would say the weight is depending on
That's
the,
right. Weight
yeah.
of order. And dependent variable would be the price. That's dependent on the weight, right? So
Yes.
price of customers order. That is correct. So the price of the customer order is dependent upon the weight of the order. Okay. Maureen, number 4. Vera and Elizabeth are hiking. The longer they hike, the more snacks they should bring. So what is the independent variable? What is dependent variable?
Number 4.
Yes.
I can't say on that. I didn't got it written down.
Oh, you can't
You
see
gotta
number.
break. You gotta break down.
Okay.
I had to read it. Yeah.
All right. All right. Can you see it now? Vera and Elizabeth are going hiking.
Uh,
They're trying to figure out how many snacks they should bring with them on the hike. The longer they plan to hike, the more snacks they should bring.
the more snacks is depending, right? Depending is not the more snacks that depends on, right?
Okay. The more snacks they bring.
The
Okay.
dependent.
Okay. So number of snacks bought. And what is that dependent upon?
You gotta break back down.
Okay. So what is the number of snacks they bring dependent upon?
Okay.
But it says here, the longer they plan to hike, the more snacks they should bring. So what's the independent variable?
The longer they plan to bike, they say here Vera and Elizabeth are going bicycle riding.
Okay. So what is the independent variable? Length of the hike, right?
Yeah.
So the independent variable would be the time they spend hiking. Time spent hiking. The time spent hiking affects the number of snacks that they brought, okay? And number 5, the last one. Okay, Alba. As a plane descends, the more time that passes, the lower the plane's altitude. So what is the independent dependent variables? The time they are descending or the altitude of the plane? Which one is dependent? Which one is independent?
The altitude of the plane,
That dependent or independent?
independent.
The plane's altitude is dependent upon what?
The descendant.
No, The number of, could you repeat the question for me again?
Okay, the choices here for independent, dependent, let me go back up here. As a plane descends, the more time that passes, the lower the plane's altitude. So one of your variables is the time that passes. The other one is the plane's altitude. Which one is dependent? Which one is independent?
I would say the time is depending on the altitude.
Now, the altitude of the plane is the dependent variable. And what is that dependent upon? Planes.
The plane,
The plane's altitude is dependent upon what, Alva?
the plane altitude depend on the plane.
Oh, what about the plane?
Well,
Altitude,
Okay, let me go
as the
back.
plane
As a
descends,
plane descends, the more time that passes, the lower the plane's altitude. So the plane's altitude is dependent upon what?
the plane,
What about the
more time
plane? The plane's altitude is dependent upon the time passed
passing.
during descending. See, that's when the plane is landing, right? The time passed during this descending is the input to the output, which is the plane's altitude. You follow, Alva?
I'm trying to figure out that one, Miss Barber. It's a
Yeah.
little bit.
And yeah, well, see, think of it as a plane landing, right?
Yes,
So the altitude of the plane, that means how high the plane is up above the ground. That
yes,
depends upon the time that passed as it's trying to land, which is descending, right?
yes, yes,
So the more time passed, the closer the plane is to landing, which means the altitude is lower.
yes,
So the plane's altitude is dependent upon the time passed while it's trying to land, which is descending. Got it?
okay, yes.
Okay. All right. So that's the end of that. Now you have I think did I send you the review, the algebra review homework?
Yeah.
Yes, I have
Okay.
them on the phone.
Okay,
Yes.
that's your next homework. All right.
Okay, okay, Miss Barber.
Okay. And
All right.
remember, we don't have class on Thursday.
You know.
Have
Yeah.
a nice Thanksgiving.
Yeah, enjoy your Thanksgiving because we won't have class on Thursday. Okay.
Yes, I know. Until next Monday.
Yes. And your
Okay.
homework you have already. So there will be
Yes.
no additional homework. Okay.
Okay, Miss Barber. Have a nice